Hello class. I've decided to put up some problems and solve them as a review for your upcoming geometry test. So in this first problem we're given this figure in this lower left hand corner. Before I go on, I just want to say that the whole value of making this video recording is that you can pause along the way and try to make sense of what's being said at that moment. Because of the fact that we're dealing with geometry and we're going to be saying just a bunch of random letters all the time, like for example, what we're trying to prove is that angle FBA is congruent to angle FCD, right? What the heck are those? So at this point it'd probably be good to pause the video and see which angle is FBA and which angle is FCD. And in general, as the video progresses and you need to pause to look at what something refers to, just go ahead and pause and see what it refers to. Alright, anyways, so we're given this figure in the lower left hand corner and we're trying to prove that angle FBA is congruent to angle FCD. What we're given is the diagram as shown, the fact that ray BF bisects angle GBC, the fact that ray CF bisects angle ECB, and the fact that angle ECB is congruent to angle GBC. Now I do have some minor markings on this figure. They kind of just denote that BF bisects angle GBC, and so because we're told that that BF does bisect that angle, that means that the two resulting angles, so that would be angle GBF and angle FBC, that result from that bisection, they must be congruent. So I've just made a little marking to try and remind myself that those two angles are congruent. And in general, when you're working on proofs, you're going to want to make similar markings yourself so that you know what you've established is congruent to what, or what certain relationships between the angles or the sides of the geometrical shapes are. Okay, so we know what we're trying to prove. We've actually been given the 10 steps on our right hand side, and so our task here is really just to come up with a justification for each of the steps that make up this proof. Now the justification for the first 3 steps is just they are given, right? We've already been told that those things are in fact facts about the shape that we've been given. Now let's look at states that angle FBC is congruent to angle FCB. Now what is the justification for that? Well, briefly, if two congruent angles are bisected, then each angle produced by those bisections is congruent to all the other angles that are produced by those bisections. All right, and just again remember that when an angle is bisected, then the two resulting angles produced by that bisection are going to be congruent to each other. Okay, so that is step 4. Let's look at step 5. Why should we assume that the diagram is as it is shown? Well, because that's a and we'll see why that's important as we come to step 6 and step 7. So in step 6, it states that ABC is a straight angle. Now when we look at the diagram, it seems pretty clear that angle ABC is a straight line or a straight angle. So our rationale for step 6 is just the diagram as shown. That's what we would write as our rationale for step 6. Now step 7 says that angle FBC is a supplemental angle to angle FBA. Now what is the rationale for if two angles form a straight line when added together, then they are supplementary angles. And we can see that when FBC is added to FBA, that they do in fact add up to make a straight angle or a straight line. So that's why those two angles are considered supplementary. Because remember, supplementary angles are just angles that when added together add up to 180 degrees. Same basic reasoning when we look at steps 8 and step 9. Step 8, what's the rationale for assuming that angle BCD is a straight angle? Because of that's how it appears to be so in the diagram. Now, why do we assume that FCB is a supplementary angle to angle FCD? Well, again, if two angles form a straight line when added, then they are supplementary angles. All right, so this is going to bring us all the way to step 10. Step 10 states that angle FBA is congruent to angle FCD, and that is in fact just what we have set out to prove. So what is the rationale for step 10? Well, it already says it up in the top left corner. I would pause this video and look at that carefully. So it says if two angles have supplementary angles, if two angles have congruent supplementary angles, then those two angles themselves are also congruent. So what's the supplementary angle to FBA? The supplementary angle to FBA is FBC, and the supplementary angle to angle FCD is FCB. Now we've already established that those two angles, FBC and FCB, are congruent. We established that in step 4, and those two angles, supplementary angles, are angle FBA and angle FCD, which we're trying to prove are congruent. Okay, but if those two angles in step 4 are congruent, then their supplementary angles will also be congruent, and their supplementary angles are angles FBA and FCD, and so that's how we know that they are congruent. Let's look at a new problem. So here, this one's actually kind of difficult. We have two lines that intersect each other. Now, what we're trying to do is find the measure of angle EBD. So how many degrees is that angle? Now, there are a few things that we do know, so let's go ahead and lay those. So for one, we do know that angle EBA is congruent to angle DBC. All right, those are called vertical angles. They are angles formed by the intersection of two straight lines, and they're the ones that are across from each other. All right, and so angles like that are always going to be congruent. One way that you can prove that easily is when you look at angle DBC, you see that when it is added to this big angle, this angle EBD, which is equal to 6x plus 6y plus 20, all right, when angle DBC is added to that bigger angle, that forms a straight line, or 180 degrees. Now, when you add angle ABE to that exact same bigger angle, so that angle that equals 6x plus 6y plus 20, that also equals a straight line. So that means that those two little angles, if they're added to the same thing, all right, which is this big angle, and when they're added to that same thing, they come out with the same sum, namely 180 degrees or a straight line, then that means that those two smaller angles must be congruent to each other, must have the same degree. All right, so we know that angle EBA is congruent to angle DBC. What follows from that is that 2x plus 2y must be equal to x plus 3y plus 10. Now, if we subtract x and 2y on both sides of this equation, then what we're actually going to end up doing is figuring out what x is equal to in terms of. All right, so when we carry out that math, we see that x is equal to y plus 10. So this is going to help us a lot in trying to figure out what x equals and what y equals. All right, so what is something else when we look at this figure that we can deduce? Well, I mentioned earlier that any one of these two smaller angles, when they're added to this bigger angle, they're going to equal a straight line or 180 degrees. So that's so that we know. Now this equation that I've added up here, angle DBC plus angle EBD is equal to 180. That can be rearranged. to be angle DBC is equal to 180 minus angle EBD. Now let's go ahead and write out what those angles are in terms of x and y. Alright, so I have that down here. X plus 3y plus 10 is equal to 180 minus angle EBD, which is 6x plus 6y plus 20. Remember that we need to carry that minus sign throughout this entire number in parentheses. So when we get minus 6x minus 6y minus 20. All right, so when we go and rearrange furthermore, all right, so what did we do here? I should explain what we did. So x no longer shows up in this new equation at all. Anywhere where there is an x, I went and substituted y plus 10 because that's what we figured out earlier, that x is equal to y plus 10. So now that we have all of the x's out of here, we're going to be able to easily solve for y. All right, so the equation is going to simplify somewhat to 4y plus 20 is equal to 160 minus 6y minus 60 minus 6y. That's ultimately going to turn out to be 16y is equal to 80. All right, when we move that positive 20 to the other side of the equation, we do that obviously by subtracting 20 from each side of the equation. And then when we bring the negative 12y on the right side of the equation over to the left side, and we do that by adding 12y to both sides of the equation. So 4y plus 12y is equal to 16y. So our resulting equation is 16y is equal to 80, so that means that y is equal to 5. Now what is x equal to? Well, we already know that x is equal to y plus 10, so x is equal to 5 plus 10, x must be equal to 15. So now that we know that, and we know that angle EBD is equal to 6x plus 6y plus 20, we can just plug in those y values. And when we do that, we're going to find out that angle EBD is equal to 140. All right, so just to somewhat retrace our steps, all right, we knew that these two small angles were equal to each other, so we set them equal to each other, and then we tried to isolate x on one side of the equation, figure out what x is equal to. And we found out that x is equal to y plus 10. We always want to try to find out what x is equal to. Now, if it had turned out that when we had moved the terms around, that it was something a little bit more difficult, like maybe it ended up being, instead of x is equal to y plus 10, it was 3x is equal to y plus 10. That's no problem. All right, if it's 3x is equal to y plus 10, then obviously x is going to be equal to y divided by 3 plus 10 divided by 3, and you just have to use those terms. It's a little bit more complicated, but it's the same basic step. So what we did was we found what x is equal to in terms of y, and then we took another equation, which was this one, that angle DBC is equal to 180 minus angle EBD. All right, once we did that, we just plugged in what x is equal to into that whole big equation. So wherever there's an x, we just plugged in a y plus 10. And by doing that, we were able to find out what y is. And once we found out what y was, we could just plug that into this equation we have for x, which is x is equal to y plus 10. All right, so let's do a problem. All right, in this last problem, we're given angle ABC. We're told that it's equal to 23 degrees and 30 minutes and 60 seconds. All right, now recall that each degree is equal to 60 minutes and each minute is equal to 60 seconds. So that makes doing arithmetic with these angle measures a little bit more difficult because they're not all on in a base 10 format. So in this case, once the number of minutes gets to 60, it doesn't go to 61. It adds 1 degree and then starts over back at 0. So we'll see how that works out when we're trying to solve this problem. Okay, so we have angle ABC, and we're told that it's equal to 23 degrees, 30 minutes, and 10 seconds. We're told that ray BD bisects angle ABC, which, because it bisects that angle, that means that the two resulting angles are congruent to each other. Angle ABD is equal to angle DBC. And what we're trying to do is find that measure of DBC. So we know that the measure of DBC will be half of the measure of angle ABC. All right, and normally it would be really simple to find out how many degrees that is, but because of the way the seconds and minutes are set up, it's actually a little bit difficult. So I want to kind of show you a trick on how to deal with that arithmetic. All right, so here, this is just what I already said. The measure of angle DBC is equal to 23 degrees plus 30 minutes plus 10 seconds divided by 2. Right. Now, if we divide the degrees, the minutes, and the seconds by 2, what we get is 11 and a half minutes. 11 and a half degrees, 15 minutes and 5 seconds. And this is mostly fine, but we want to get rid of this half degree. We want to put that off into the minutes area. How much is a half a degree? Well, if 1 degree is equal to 60 minutes, then a half a degree is equal to 30 minutes. So we just take that half a degree, that extra half, convert it into minutes. We know that it's going to be 30 minutes, and we just add that to our minutes count. 11 degrees plus 45 minutes, 15 plus 30, and 5 seconds. Right? And we can reverse the process to see how we would go about multiplying. All right, so what if we're asked to multiply 11 degrees, 45 minutes, and 5 seconds by 2? All right, well, if we multiply each of these things by 2, all right, if we multiply the 5 seconds by 2, we get 10 seconds. If we multiply the 45 minutes by 2, we get 90 minutes. And if we multiply the degrees by 2, we get 22 degrees. Now, remember, you can't have more than 60 minutes. We have 90, so we got to do something with those excess minutes. Now, there's 60 minutes in a degree, so what we're going to do is just subtract those 60 minutes, that 1 degree's worth. So we subtract 60 from 90 to give us 30 minutes. And we're going to take those 60 degrees that we've subtracted and just add that as 1 degree to our degree count. So instead of having 22 degrees, we're going to have 20 degrees. So again, let's just look at this process as a whole. We multiplied our 11 degrees by 2, our 45 minutes by 2, and our 5 seconds by 2. That gave us 22 degrees, 90 minutes, and 10 seconds. Now the highest number of minutes you can have is technically going to be 59, because once you have 60, then you have a whole degree there. So we had more than 60 minutes, so we took away those 60 and said, okay, that's 1 degree. So we added that to our 22 degrees to get 23 degrees. And then we subtracted, then we just included those 30 remaining minutes in our count. All right, and so that's how we work with the minutes and seconds when solving problems like this.